Hello, hello, this is Postgres FM. My name is Nikolai, Postgres AI, and as usual, my co-host is Michael, PG Mustard. Hi, Michael.
Hello, Nikolai.
So, there is a topic I wanted to discuss, and it's widely used by those projects which are grown-up projects. Usually in tiny projects and new projects, this topic is skipped. And this topic is related to my favorite area in Postgres administration. It's zero downtime changes. First of all, schema changes, right? And we all know that it's a mistake to create index without the word concurrently live, because it's not a live operation, not online operation. This is such term online operations. It means it's blocking other sessions which deal with the same table, and it's bad. While create index concurrently is good. If it succeeds, it takes roughly 2 times longer because it scans table twice. But if it succeeds, we have an index and nobody is blocked, which is great. And we discussed many times that there are many changes which are tricky. For example, if you just add a column, you can block others if you are blocked by, for example, AutoVacuum running in transaction ID wraparound mode. And in many cases, there are tricks how to, instead of single step, do multiple steps but achieve the same result in truly online fashion. And let's talk about some details here. First of all, how we introduce new constraints on existing columns. First of all, check constraints and foreign keys.
Yeah. Should we talk about if we didn't have this feature, so if we didn't have the ability to do it in multiple steps, if we couldn't set it not valid first, what would we do, or would we live without the constraint? I think it's worth discussing what kind of lock is taken and why we need this feature, or why this feature was implemented in the first place.
Yeah. Let's talk about this. If we imagine that we have already a column and we want to change something about it. For example, we want to change default. It's easy because default is only about the future. Postgres doesn't need to check the existing rows, doesn't need to change anything in existing rows. It's only some metadata change. So alter table, alter column set default, super fast, unless we acquired a lock, right? And this topic is important almost to any alter. It's important to lock acquisition. In some cases, you need the exclusive lock acquisition. In some cases, also exclusive. But I remember differences. For example, if you alter table, adding a table to publication, to enable publication with logical replication, there it's not that bad. But if we alter table, alter column, set default, it's quite bad. It's fast, but you need a lock. And if you cannot acquire a lock, you are blocking others. But this simple example, it's super fast, nothing to worry about in terms of this operation takes long. Lock acquisition might take long, right? And we need to take care of it. We need to have a low lock timeout and retry logic, be ready to do it. Again, I'm discussing here, my comment in the beginning was specifically we talk about projects which are grown already and they have significant load, say more than 1000 TPS. Other projects also experience it, but they just don't notice because traffic is too low, right?
Yeah, and we did a whole episode on the general case here. I think we did one on zero downtime migrations, which I think we went into detail on the general case, didn't we?
Yeah, I agree. If you are interested in this topic, you listen to this episode, please listen to that episode as well, because today we are going to go deeper in specific narrow area, which is not that narrow. If you take any project, take 3 years of its lifetime, definitely these things happen. So adjustment of default is relatively easy. We need just to remember about this lock acquisition issue. But if we go further, for example, we created a table, it has... Oh, by the way, another comment. Folks who just prefer JSON-B or very flexible schema would say, it doesn't matter. We keep everything in text, no additional constraints. Let's application take care of everything. And I understand this position, but I fully disagree with it because I think database is the only, database constraints is very powerful mechanism to ensure that data is clean and high quality, right? So
And I think there are even extensions that help you validate schemas even within JSON B columns.
Yeah, right.
And I think they're using constraint.
But
Yeah.
anyway, constraint capabilities in database system, it's very powerful. And when you shift this to application logic, you should be 100% sure that in future you don't write second application which deals with the same database or different parts of it in different code, or don't use some UIs which can allow people to change data and bypass those checks which are left in your application. So constraint validation should be done closer to data, and this is database system. Okay, default, easy. Next, for example, let's jump to the main case. We have not null. Not null is a tricky constraint because in my opinion, it should not exist because we have check constraint, which is much more powerful. It's a superset of not null, right? It includes it because we can say check this column is not null. That's it. Easy. But is not null also it exists because it's SQL standard. Also, like I think it was created before check constraint was created, added to
Makes
standard.
sense.
I guess it's my guess. Might be wrong.
I'm not even sure. A check constraint is definitely in the standard.
Check constraint should be in standard.
Okay.
Not 100% sure, but it would be very strange if not. But it's obviously like, why do we have not null constraints at all? We have check constraint, right? And interesting that if you define a primary key, it requires a not null constraint. Not like it needs it. It requires two things:
inherent.
unique constraint and not null constraint. And fortunately, since Postgres 12 optimizations, we can forget about this distinction and we can build a check constraint with not null, and implicitly not null actual constraint will be built efficiently on top of our check constraint and primary key will use it. But some implementation detail, right? Before 12, it was nightmare. And I remember discussing with very experienced DBAs, discussing how we can introduce not null constraints, like, because not null doesn't support this two-phase approach we discussed today, right? You cannot define not null constraint, first not valid and then validate. It's not possible. And before 12, it always led to full table scan. And I remember experienced DBA said, you know what, like between us, we just adjust system catalogs because we know there are no records violating these constraints, so we accept this like, we just do it. Since like Postgres 8.0 or something, like that's it. But yeah, this is an ugly hack actually. I mean,
Risky if you don't know exactly what you're doing. Yeah.
Well, it seems like not super ugly, not super risky, but fortunately, since Postgres 12, we don't need it, and we can define check constraint in this two-phased manner, and then not null constraint will be implicitly defined very fast without full table scan. So, for example, okay, we create check constraint, we define some logic in this. For example, not null or something else. For example, we can say all integer values in this column should be positive.
Yeah, well, it's super flexible, isn't it? You can pretty much define whatever you want via any query via a check constraint. It's really cool.
Not any query, unfortunately. There is huge limitation.
For multiple tables, you can talk about columns.
Exactly.
Well, what is the limitation?
You need to stay inside the same table context. You cannot refer other tables, unfortunately.
But it's pretty powerful, right?
Of course,
you can have multiple. You can reference multiple columns within the same table. But yeah, the normal use cases are like this number cannot be negative or like so
or odd or something. This number should be odd number.
I've not seen that in the wild, but yeah, like or certain.
For example,
maybe like a maximum value or something. Yeah.
Yeah, ranges for many things can be. It's good. It's good practice because this is how you ensure data has high quality. Right?
Yes.
So, and that's it. But imagine we have a billion rows table, which is which should not happen. You should have partitioning in place and don't allow it to grow beyond a few dozens of millions of rows maybe. But it happens all the time in grown projects, grown up projects. I see it billion plus rows all the time. And we define this constraint and how Postgres, like if we just say alter blah blah blah, once lock is acquired to adjust metadata system catalogs, Postgres acquires lock, and then what it does, of course it goes and checks existing rows to see if there is any violation. If there is, it will roll back. And this is super bad because for 1 billion rows, it takes a lot of time. Full table scan.
And while it's doing that, it's blocking any new writes.
Exactly. Not only writes, selects as well because it's an alter.
Yeah, true.
Yeah. So it's super bad. This is where some engineers have feeling like they promised us that selects are not blocked. What's happening here? Well, they are not blocked by writes, regular writes, but you are changing the rules right now, right? Rules, I mean, you're changing the schema. So this is not simple, right? So you acquire the lock, you start reading this. It can take a lot, like minutes, maybe more, depends on disk capabilities and actual table size. And even selects are blocked. This is super bad. That's why we have for check constraints, not for not null, for not null we don't have it. For check constraints we have ability to say not valid. We say alter table blah blah. We say add constraint and then we specify not valid flag. It's a flag. By the way, terrible naming.
Yeah. Or confusing. If you had to guess what it was without knowing, I think you wouldn't get the details right.
Right. Why is it terrible? Because once this and this transaction is fast because it doesn't check the existing volume of data at all. It just defines this constraint as it was as the table was very small, like empty, super fast. Just lock acquisition is needed. Again, we need low lock timeout and retries. This is the rule.
But I think that's not the bit that would have confused me. The thing that would have confused me is that it will be checking new rows and
Exactly.
updates.
Yes.
That's what's confusing, right?
You okay? You brought it before. It's okay. Yeah, but I mean, mechanics is like we create constraint like table's empty, and that's it. And it's marked not valid in table definition if you use \d in PSQL and you think, oh, this is not valid constraint, I don't care. And I remember I was preparing first complex transformation of 4-byte primary key to 8-byte primary key integer. And it was very complex operation, like I think 7 steps. Each step was reversible. And I remember, for the sake of reversibility, it was not about check constraints, but it was about foreign keys. It's quite similar there. You can also say not valid for foreign key. And I left not valid foreign keys for some like shadow table or old table or something. And I thought they won't be used. It was a huge mistake, led to some bug. Unfortunately, I quickly realized, okay, not valid doesn't mean it's not working. Right? It's still working. It means that it's applied to all new writes, inserts and updates, not deletes. In the case of check constraint, deletes don't matter, right? Because we don't need to check. Yeah. But in the case of foreign keys, deletes also matter, right?
Yeah, true.
Yeah. Because if you delete the referenced row,
referencing row.
Yeah, referencing row becomes an orphan if, yeah. So for all new writes, let's say writes, like aggregate all changes of data here. And if you define check constraint, you try to insert. If you have, for example, let's say we have not null. You try to insert null, it says, okay, violation of not valid constraint. How does it sound, huh? It sounds not good. It's confusing. So I think a better name could be, I had an idea yesterday we were discussing with one client. I forgot What would be better? Not verified, maybe, right?
Mm,
Not verified.
yeah, it's better. Naming things is notoriously difficult, right?
Yeah.
But yeah, we've got this now and we're stuck with it. I think that distinction between the types of rights is quite important though. Like, I think I would then have gone away and thought, oh, insert, like if I change that column, it will validate it. But
Right.
I wouldn't have realized that if I changed a different column.
or no columns at all. As you remember, if it
Yes, good
update,
point.
my favorite example, update set ID equals ID, doing nothing logically, but physically it produces a new tuple. A new tuple is also check against this not valid constraint, and
Yeah.
it complains violation.
Yeah. So in case that wasn't clear, if that tuple has a violation in it, and because we haven't validated yet, it didn't fail, then it tries to write that tuple again with the invalid column. So yeah, not verified feels good actually. Yeah, that makes sense. But I don't think the side effects of this, leaving a constraint in a not valid state, are obvious, or at least not to me on first when I first came across it.
But despite naming, I think the idea that it's already working for new rights it's great because
Yes.
it gives you opportunity to say, okay, we now are covered by all future rights, all future data. Now let's take care of existing data. And how we do this? How do we do this? First of all, we need to. I would not go straight to alter table validate constraint, which scans the table in non-blocking way. This is the key. It doesn't block anyone. It just scans it, and if everything is clear, it updates system catalogs again. I think lock will be needed, maybe, right? But it only in the end. I'm not sure if retry logic is inside this. It's interesting
I
question.
looked it up. There's a really good note in the alter table docs, and it says validation acquires only a share update exclusive lock on the table being altered for like a check constraint, and there is an additional lock when it's a foreign key on the. If a constraint is foreign key, then a row share lock is also required on the table referenced by the constraint. Which
So
makes sense.
yeah. It might fail. For example, again, if AutoVacuum is running transaction ID wraparound prevention mode, I think can be blocked by it. But it's not like. Fortunately, we can retry it multiple times. Yes, it will read whole table, quite data IO intensive, disk IO intensive operation, but it's already much better. The key is we don't block anyone, and if we succeed, it's great. But we might not succeed if there are nulls, or if it's different check constraint, if there are rows which violated. In this case, before doing this second step, there should be an additional step in between. We should take care of violations ourselves. Either we need to delete those rows or update them, setting value, right?
Well, question: why not do that before the
Exactly, good question.
setting that? Okay.
Yeah, good question. And I think if we think like, since not valid constraint already covers all future rights, I would prefer first introduce constraint, then clean up, taking care of violations in one way or another. It's very domain specific. And then validate constraint. Why? Because in this way, we don't introduce any gaps where new violations can be added, right? If we move the step of cleanup before, like if we have it as the very first step, in this case, what is like, again, depending on the logic of application, but in general case, after we're done and before we start creating constraint, some new rights might happen and violate it once again, right? And this is bad.
So yeah, I guess it depends how many we've got, but I would still, like, if we've got loads, then we're gonna end up with a not valid constraint for quite a while we clean up quite a lot of data. My feeling would be, I guess both might be the solution. Check, like, get an idea of how many you've got in your existing data, work out a plan for fixing those, deal with the ones that you knew about at that time. So some snapshot from like yesterday, we checked which rows were in violation. We've got this script to fix them all up. We've run that. Now maybe we check again, see if there's any new ones, or maybe then you flip it to not valid, because at least you're only going to have a day's worth of, or however long it takes your company or your organization to deal with those. So it could be that you do it before and then in between.
Yes, unless we don't want to scan table too many times, because we already need, when we do it to clean up, and also this validate constraint step, the final step, also needs to do it. But maybe we should do it before, like this very first step, then introduce constraint, do it again, and then validate. Maybe this is the ideal situation. But regardless of that, if we just blindly say, okay, we introduce constraint, then clean up, then validate, this may lead to not understanding that not valid constraint is already applied to new writes. This may lead to late code fixes. And if application code or whatever continues to perform new writes which violate constraint, this is a problem because it will bring more and more, right? But there is another problem also. Exactly what you brought. Like, imagine we perform an update changing the other column. For example, I don't know, like if it's some post or something, we just edit title. And then there is some additional column which we want to be not null. We had some nulls, we want to convert them to, I don't know, false or zero or something, because we finally realized we don't consider nulls as zeros or empty strings. And then we have a bunch of rows which still have nulls, and we already introduced constraint. Then user goes and tries to, for example, edit a title, and cannot because constraint is already working. And during editing a title, Postgres, as we know in MVCC, Postgres copies the whole row. It's physical row. It's called tuple or tuple, right? And new tuple is violating not valid constraint. So editing of title is broken. It means we must clean up as the first step, accepting gaps.
So this is why we always need to validate the constraint eventually. Like when I say eventually, I mean at the end of this process, and ideally as quickly as possible to avoid issues.
Do you see how deep the topic is?
It's
interesting.
For sure.
Unexpectedly, right?
What do you see in the wild? Yeah. Do you see people trying to do this like almost instantaneously? Because if we run them back to back, it's still much, much better than it's much better than the alternative, introducing the constraint without the not valid.
Honestly, I think I saw systems, maybe it was smaller projects, and maybe it was because of me where we made mistake and did clean up as the second step, not having it before the first alter table. It should be before the first alter table, definitely. And we just didn't notice this bug. I mean, it's a bug of application. It's not a bug of Postgres. When user tries to edit a title, but because of some additional column violation, what's happening here? And now I'm more cautious about it, so I would put it on the first place. And
So just to clarify, first step, we manually check for violations. Yeah, exactly. So you know what I mean? Like we don't use the validation step to validate whether
first step is get rid of violations even before you introduce constraint. Then you introduce not valid constraint, then ideally once again get rid of violations because maybe we had a gap, maybe new came, and then validate constraint.
I actually think I'm wrong there. I think we'd be better off checking for violations, fixing them, check the violations again, and if you find any, don't go ahead with your plan because you've still got a problem at the application level of bad data being inserted. So probably then don't get started because you need to go back and stop.
This algorithm needs to be visualized already.
Yeah. But do you see what I mean? Because otherwise we're going to have errors.
Yes, exactly. But how does it change it? Okay, clean up, create constraint with not valid, Why you are shaking your head?
I'm talking about leaving a gap at the beginning. So clean up
Wait.
the existing data, wait a
Wait is
while,
a good idea. Yeah, yeah. To see if
see if you need to clean
okay,
up
no.
again.
First, fix your application. Fix your application, not to produce
Sure, yeah.
wrong data anymore. Second, clean up. Third, one more step. Wait,
Yeah.
like days, weeks, I don't know. Then introduce. No need to second clean up. Introduce constraint. Why? Okay. Second
Or
clean
check.
up.
Why not check? Why not
Check
first?
without cleanup. Okay, I mean just yeah.
It's just a
check.
minor step. It doesn't take long.
Okay.
One more scan of the table, though.
Okay. This is full fledged. Okay. One more time. Fix application code. Clean up. Check and clean up if needed again. But if clean up needed again second time, it means code is not fixed yet. This is great. Then alter table at constraint not valid. And then what do you think? Do you need new cleanup? Maybe no already, right?
Shouldn't do, right?
Yeah. Yeah.
Well, because at this point, if you just validate it, if you needed to clean up, it will fail.
Yeah, it's similar to just checking.
Same.
Yeah. So yeah, I agree. Let's remove cleanup between two alter table steps but have two cleanup plus additional check and some time between them. Yeah, that's great. Final question I have here. Could we have just alter table concurrently and have less headache when doing these things? What do you think? For example, if you create similar situation, create index concurrently, create unique index concurrently. It's not just index; it's constraint basically. And if we have duplicates, it will fail, right? What we need to do in this case: clean up manually invalid index. It will be showed as invalid, and then make a new attempt from scratch.
You said the index there, but did you mean constraint?
Well, constraint will be created implicitly. There's a subtle difference between unique indexes and constraints. Let's not go there. And
Okay.
I know places in Postgres where confusion is like violating logic. I have a patch proposed 5 years ago or so. Nobody took care of it. It's okay. Anyway, when we create a unique index, logically we are building constraints. So if we have duplicates, this operation will fail, leaving invalid index behind because this attempt also to phase, it's just single line of code, but it's to phase, right?
Okay,
We need to drop that index again concurrently and then start from scratch. Again, we need to clean up duplicates and start from scratch. How about here? We could say alter table concurrently, alter table blah blah, like add check constraint concurrently. If there are problems, it would fail, and we need to clean up and try again. I don't know.
I don't understand the reason. I never really thought about this before, but why does create index concurrently, if it fails, leave behind? Why can't it fully tidy up after itself?
Because it's not
if it fails?
transactional.
But if it's not transactional already, why can't it do the drop index? Like, why can't it know that it's left?
Yeah, it's a good question actually, and it could drop index concurrently. Yeah, it's a good question. I will think about this.
There's probably a reason, right? Like, people would have thought of that. So I imagine there is a good reason, but I don't know it.
Maybe it's just easier to implement. That's it. I mean,
maybe, but it would help. Like, that would be a good feature if it's not really difficult.
yeah, user should be okay just with error message.
Yeah, exactly. It didn't work. You're back where you started, even if behind the scenes several transactions.
Fix your duplicates and try again. Yeah, but if you don't use explicit naming for your indexes, there is a risk that you had 10 attempts and didn't notice that you have 9 invalid indexes left behind because you didn't check the definition. This is a risk here. If you use explicit naming, of course, it will say the index with such name already exists, right? Or no? Index concurrent.
I actually don't know for invalid. I assume so.
I think yeah, it will be this index. Yeah. So I always prefer to use explicit naming for indexes just to control the naming schema, like understanding which columns are indexed and so on. But also because of this, for to better control of my attempts. If it's concurrently, it's always concurrently, almost always. Yeah. So anyway, back to this alter table, add constraint, check constraint. Concurrently, why not? It could just do 2 phases. First phase not valid. Second phase validation. If validation fails, cleanup or no, it's a separate topic now. You detach this topic.
I prefer cleanup, but yeah.
But wouldn't it be so great?
Yeah. I feel like concurrently is coming up in every episode these days. It's good.
Great, yeah. So alter table concurrently.
I think it'd be a great feature.
It's not an easy to implement. I'm sure.
And again, non-transactional. It's another one of those
Exactly.
things that would have. Yeah.
It means that there is a promise, Postgres has transactional SQL, but when you start working, it's already so. Like in real life, we don't have transactional DDL because creating this concurrently is not transactional, and these steps, when you like split it to several steps, each one of them is transactional, which is great, but sometimes you cannot reverse this, and overall you lose some data or something.
Yeah, I think it's fair to say we do have transactional DDO in Postgres, but it's not practical in larger projects with high load because you just can't afford the downtime that comes as a result of that transactional DDO. So in medium to heavy load, large enough setups, we don't have transactional DDO, or not practical. We can't practically use it. So these practical solutions are really valuable, I think. The other approach seems to be, like the completely rewriting the table type approaches, like we talked about last week. Or there's another project that maybe it's definitely a whole nother topic. But have you come across PG Roll? I think it's been brought up a couple of times on the podcast.
Yeah, in the past, full rewrite of a table, or
yeah, exactly. I think that's another solution to this, right?
Just to introduce constraint. Thank you. No.
I don't know if that's what they do for this, but I think that's how they handle most schema changes. So
I understand that.
It's heavy-handed, but it does also solve this problem.
Yeah. Now I remember PG Squeeze. When we discussed PG Squeeze, we discussed like changing order of columns. This makes sense, and of course, like concurrently, not concurrently. Yeah. So,
and the other, I guess, one final solution is again super heavy-handed, but you could logically replicate to an instance that has the constraints that you want in place already. But lots of huge amount of
when we want to add just constraint, we need just to read everything to ensure there are no violations. It's not a big change. It's just adding a restriction. So we don't need to change data.
Yeah, shouldn't be.
Yeah. Anyway, I think that's it. What I wanted to discuss.
Nice.
Anything else?
Yeah, super useful feature. I think I'm hoping more people become aware of it now.
You mean alter table concurrently doesn't exist?
No, I mean not valid. I mean alter table add constraint not valid.
Not valid, and a little bit confusing naming. So watch out. New writes are already being checked.
I'll include some links to the documentation because that explains it pretty well as well.
Great. Great. Thank you.
Nice one, Nicola. Thanks so much.
See you soon. Bye-bye.
See you soon. Bye.